Let's talk about the CrowdStrike issue. So 10 days back, computers worldwide which were running on Windows started to getting this blue screen of death. Now this blue screen of death is very infamous with Windows user, but this was not a single incident. However, it was a global incident which took down many enterprises including airports, flight systems, hospitals, and educational institutions. Flights were cancelled, people were stuck at airport, hospitals cancelled their elective surgeries. This was one of the biggest incidents in IT based on the number of endpoints impacted. So in this video, I am going to dig deeper and understand how this incident happened that shook the world.
Broadcast channels, Australia, even ours here, we had those blue screens everywhere.
The list of global companies impacted included Microsoft. It was one of the biggest cyber outages to have ever taken place.
Now let us see what was the impact. It was a truly global incident. A total of 8.5 million systems or endpoints crashed. Globally, more than 5,000 flights were cancelled. Around 5% of the flights that were scheduled on that Friday. The financial impact is estimated around 10 billion US dollars. At the time of the incident, CrowdStrike had around 24,000 customers, which included most of the organizations from Fortune 500 and Fortune 1000, and CrowdStrike stock fell over 11% in that single day. So now let's talk about the timeline of the issue. So the incident started at 4:09 UTC on July 19th when CrowdStrike deployed a faulty piece of code for their Falcon sensor security software. Now this software mostly is used on different endpoints for Windows, Mac, Linux, etc. but it impacted the Windows user the most. Immediately around 4:30 UTC, Microsoft Azure based Windows machine started to crash. Now this was the first time it was realized there was something wrong going on. Immediately after some time, it impacted other cloud vendors, for example GCP or the Google Cloud or AWS based Microsoft Windows machines. So at 5:27 UTC, CrowdStrike reverted the update so that any machines which got the update before that time were impacted. So it essentially cut the wire on that update so that most of the Windows machines that didn't receive the update were not impacted. At 7:15 UTC, Google said that the issue was because of CrowdStrike. Within 1 hour, at around 8:15 UTC, CrowdStrike CEO George Kurtz confirmed that the issue occurred because of CrowdStrike's faulty piece of code that impacted the Windows endpoint. Now let's look at the PIR. Now this preliminary PIR is what has been shared by CrowdStrike, and they talk about what happened in detail. Like there is a mention at 4:09 UTC, the Windows host that were running sensor version 7.11 and above had this issue. So only the systems which were online from 4:09 and 5:27 UTC which got the update were impacted. The cause of the incident is what CrowdStrike has mentioned. The crashes were due to the defect in rapid response content which went undetected during validation checks. Now keep in mind, CrowdStrike has acknowledged that these problems were not detected at their validation checks. When the content was loaded by the Falcon sensor, this caused an out of bounds memory read, leading to Windows crash or blue screen of death. Now this is a specific issue with Windows, and we are going to understand that also why Windows system have this issue. They have also provided what CrowdStrike is doing to prevent this from happening again, which is basically a lot of action items that they are going to do. This is the preliminary PIR. PIR is a post-incident report and it's a preliminary one. So there would be a secondary PIR as well, which would be much more detailed, and that's what I'm expecting as well. Now let us talk about CrowdStrike and its software Falcon. CrowdStrike is one of the company which is running on 298 of the Fortune 500, 538 of Fortune 1000, and 43 of the 50 United States. So it is used by 8 out of top 10. And if you look at the Magic Quadrant of endpoint protection platforms, CrowdStrike is one of the leaders. Why? Because of their software Falcon. Now what Falcon does, let us take this an example. So you are an IT engineer in a very large company. Now you want to monitor what people are doing on their endpoints, what type of software they are running, is there any anomaly in terms of how they are using their system. It might also be a case, for example, somebody has downloaded a software which has caused a ransomware attack you would identify, detect it early, and isolate it as soon as possible so that ransomware attack does not propagate throughout the network, can impact the company properties. Now what happens is that you have to use an endpoint management software, and it's very difficult for a single person or a small IT team to monitor thousands of systems. So we need to use machine learning here. Now what happens with machine learning, these pieces of software can detect anomalous behavior. If they see any outlier in their behavior, if they see any pattern which is not usual, they would trigger an alert. They also need an updated version of threat patterns and threat detection across the new threats that are emerging on day-to-day basis. Whenever there is a threat landscape change, there are new emerging threats, these threat definition files keep on updating. That's what an endpoint management system does. And why it is required? Because it's very eminent in today's world. We identify, detect, and isolate a threat early so that we can protect an organizational asset. So let us understand why we get this blue screen of death on Windows. So if you think about a random access memory that we have, we can generally think of it in our memory. In the operating system, we'll have two spaces. First is the kernel space where all our device drivers, generic drivers, etc. set. Now if you want to compare this, think of it as your brain. Your brain is something similar to memory. The important functions that, for example, controlling your heartbeat, controlling your essential body function, for example, your digestive system, your hormonal systems, etc., everything is controlled by brain. You don't have access to it. So think of that functions as the kernel space. As a user of your body, you don't have access to that space. Similarly, in memory, there is a space called user space, where we have all the application code, etc., and it does not have any access to the kernel space. However, because the antivirus software, or in this case, endpoint management software, require extensive permissions so that they can manage processes, see what is going on the system, they sit inside this kernel space, which happened in the case of CrowdStrike Falcon as well. Now the CrowdStrike Falcon sits inside the kernel space, and in case of any out of bound memory error, it will crash the system. And why this is a special case for Windows? Because of a lawsuit where Windows had a lawsuit with European Union, and to enable these antivirus software and endpoint management software, they have to always provide that backward compatibility so that these software can run in the kernel space, rather than, if they would have wanted, they could have provided an API sort of functionality which these endpoint management software could have used, and they could be limited to the user space. So because of that lawsuit, which was filed I think in 2009, this backward compatibility functionality had to be created. So this is the biggest issue, and we won't be able to stop such kind of issue again in future. Now let us understand how software is deployed in modern day systems. Now this is a normal CI/CD pipeline. What happens when a developer is pushing a code on any version control, for example Git? It would run a pipeline, which are a series of steps, and these series of steps can be different for different type of software and different type of application code as well. So let us take an example of this simple pipeline where as soon as I push the code on my version control system, for example Git, the pipeline software would trigger a build. So build is basically you are building the software package, and then it will perform some unit tests depending upon what type of test cases I have written for unit test. Once unit tests are done, it will do an integration test, which is basically working with other components or that software. When all these tests are done, we deploy it to a staging environment. Now this staging environment is basically a controlled environment which is similar to prod, and we can perform some more tests on that staging deployment. And once given a green from the staging environment, it is deployed to production. Now what happened here, after the production deployment, it was deployed to all the systems across the world. A better approach would have been if they would have taken a staged approach. For example, canary release, in which you can deploy to 5% or maybe 2%, 1% depending on what your risk criteria is, and you can deploy to a smaller user group. Once you deploy on this smaller user group, which is randomly selected, you can see if there is impact. Now then you can scale up and deploy to the next stage. So this is a stage deployment. There are multiple types of stage deployment, but this approach would have been much better in case of a global system deployment. Now this is what was missed in CrowdStrike. As soon as the software was released, it was deployed to throughout the world. Will this happen again? Well, yes. So brace yourself. If you enjoyed this video, do share. Thanks for watching. See you.